Okay, good day, engineers. Our last topic for discussion, thermodynamics 2. On this topic, we have mixture involving ideal gases. We have mass or gravimetric analysis. We have M is equal to M1 plus M2 plus M3 plus so on. Okay? Until the mass will end. Okay? Volumetric or molar analysis, the same. B1, B2, B3, B1 plus B2 plus B3, and so on. Dalton's law of partial pressure, P is equal to P1 plus P2 plus P3 plus so on. Specific heat of mixture, we have MCP, M1 CP1 plus M2 CP2 plus so on. The same with MCB, where CP is specific heat at constant pressure, CB is specific heat at constant volume. You have two-phase system, pure substance. Pure substance is a working substance that has homogeneous and invariable chemical composition even though there is a change of phase. Example, H2O and NH3. Tubig or water and ammonia. Working substance is a substance which energy can be stored or from which energy can be removed. The PV and TS diagram of pure substance, okay, we have the pressure volume diagram. Remember again, okay, in your thermodynamics, this curve, okay, this parang tutoy, okay, sorry for the word, okay, or ano ba to? Kulugo. This straight line going to super critical region. Okay, this line is what we call saturated liquid line rather. And these spaces here in the pressure, okay, in this pressure, mas malapit sa pressure na vertical line, that is what we call compressed or subcooled liquid region. Then, yung pinaka-tutoy na yan, that is supercritical region dyan. Basta dyan, critical region yan. Okay? Or that is what we call critical point. Huwag mong itatouch yan kay critical point yan. Next, we have this line naman na paslan that is your saturated vapor line. Tapos, dito mo sa na ito, space na ito, space here, that is superheated vapor region. And yung nasa gitna, that is your wet region, or sometimes that is what we call mixture. Okay, again, pareho naman, TS diagram mo. Okay, saturated line mo, ito, yung parang may bukol, no? Yung may bukol, itong space na may bukol-bukol, parang dede. Itong line na ito hanggang doon, that is your saturated liquid line. Again, this region, compressed or subcooled region. Critical point again yon. Alam nyo na, bakit critical point dyan? Okay? Then, here, this line that is your saturated vapor line. Ang sa taas niyan na line or dito, that is your superheated vapor region. Again, yung nasa gitna, wet region or mixture dyan. Okay? Properties of pure substance with illustration. Saturation temperature is the temperature at which liquids start to boil and vapor start to condense. Example, water boils at 200 degrees Celsius at a pressure of 1.55 megapascal. Ang subcooled liquid naman is a liquid whose temperature is lower than the saturation temperature corresponding to the given pressure. Example, liquid water at 50 degrees Celsius and 97.78 kilopascal is subcooled liquid since 50 degrees Celsius is less than 99 degrees Celsius, or that is Tsat at 97.78 kPa. You can use your tables, thermodynamics table, to find this values. Compressed liquid is a liquid whose pressure is higher than the saturation pressure corresponding to the given temperature. Example, liquid water at 105 kPa and 90 degrees Celsius is a compressed since 105 kPa is greater than 70.14 kPa or PSAT at 90 degrees Celsius. Saturated liquid naman is a liquid at saturation temperature or pressure whose temperature is equal to the boiling point corresponding to the given pressure. It has no vapor content. So example niya, liquid water at 50 degrees Celsius and 12.35 kPa is a saturated liquid. Since the given temperature, 50 degrees Celsius is equal to 50 degrees Celsius, Tsat at 12.35 kPa. Tingnan nyo ito sa inyong thermodynamics table. Kung makikita nyo, dun sa steam table or water table, steam tables nyo. Okay, please, practice this one. Dapat sa thermodynamics 1 pa, alam nyo na ito. Vapor is a term given to a gaseous phase that is inconstant with the liquid phase. Example, steam. Again, we have saturated vapor naman is a vapor at saturation temperature and pressure. It has no liquid or moisture content. Example, steam at 300 degrees Celsius and 8.58 MPa. Okay? Superheated vapor is a vapor whose temperature is higher than the saturation temperature corresponding to given pressure. Example, steam at 350 degrees Celsius and 11.88 MPa is superheated vapor since 350 degrees Celsius is greater than 324 degrees Celsius. Tsat at 11.88 MPa. Please, again, look at it in your steam table or thermodynamics table. Degrees superheat is the difference between the actual superheated temperature and the saturation temperature. Example, find the degrees superheat of steam at 350 degrees Celsius and 8.58 MPa. Okay, the solution will be SH or degree superheat mo, actual temperature minus saturated temperature, where sat temp is equal to 300 degrees Celsius, Tsat at 8.58 MPa, actual temperature mo 350 degrees Celsius. So, thus, degree SH mo is 20 degrees Celsius. Degree subcooled naman is the difference between the saturation temperature and the actual subcooled temperature. Find the degree subcooled of liquid water at 50 degrees Celsius and 19.94 MPa. Again, you can find it here. You can find it at your steam tables na pinapaprint ko sa inyo. Solution, we have SC is equal to sat temp minus actual temperature mo. Okay, actual temperature mo, 50. Okay? Sat temp mo, makikita mo doon, Tsat at 19.94 kPa, 60. So that is minus mo yan, magiging 10. Ang weight vapor mo naman is a mixture of saturated vapor and saturated liquid. Yan yung sabi ko kanina, na that region is also mixture. Example, steam at 15 MPa and 310 degrees Celsius is a wet vapor since 310 degrees Celsius is less than 342.24 degrees Celsius, Tsat 15 MPa. Quality of wet vapor is the fraction or percentage by weight that is saturated vapor. It is the ratio of the mass of saturated vapor to the total mass of the mixture. Whereas quality is equal to X is equal to mg over mt. Whereas your X is quality of wet vapor, mg is mass of vapor, mt is mass of the mixture or wet vapor. Percentage moisture is the fraction or percentage by weight that is saturated liquid. It is the ratio of the mass of saturated liquid to the total mass of the mixture. Okay? Percentage mixture mo yung Y, mf, mass of liquid, mt, mass of the mixture or wet vapor. Critical point is a point that represents the pressure and temperature at which liquid and vapor can coexist in equilibrium. Properties of mixture or wet vapor or steam. Okay? Pag-aralan, this your guide. B is equal to BF plus X BFG. U mo naman is UF plus X UFG. H is equal to HF plus XFFG. Entropy mo, again, specific volume, internal energy, enthalpy. Entropy is equal to SF plus XSFG. BFG is equal to BG minus BF, UFG, UG minus UF, HFG, HG minus F, HF, SFG is equal to SG minus SF. Where can you find this FF na ito? FG na to. Okay? You can find it in your thermodynamics table again. Okay? At a corresponding temperature or pressure. Okay? Guide to determine the phase of the working substance. If the pressure given is, okay, ito ang guide nyo ha, if the pressure given is greater than the saturation pressure, okay, or Psat mo, that is compressed liquid. Okay? If the temperature given mo is less than your Tsat or saturation temperature mo, that is subcooled liquid. Kapag ang pressure given mo naman is less than the Psat, superheated vapor. And kapag ang temperature mo naman is greater than the Tsat, superheated vapor. Okay? Familiarize this. Where B, specific volume. Okay, nasabi ko na ito kanina. Note. Okay, take note. The properties of liquid and vapor at a given temperature and pressure can be found in steam table and molar chart. Okay, just practice, exercise steam table and molar chart. Okay? You can find it in Google. Sa Google lang yan. Meron yan. Okay? Process involving pure substance. Vapor, steam, and ideal gases have similarity in their process, but ideal gas equation are not generally applicable to vapors. So, isometric or isochoric or isobolumetric process is an internal reversible constant volume process of pure substance. Again, meron na tayong PV and TS diagram. Okay, from state 1 to state 2. Ang state 1 mo, that is superheated. Going to state 2, that is mixture. Tingnan nyo. Kung TS diagram mo, titingnan mo, superheated siya. From state 1, punta siya yung state 2, mixture. Okay? Ano nangyari? Ang entropy mo, pababa. Diba? Ito naman, ang pressure mo, pababa. Okay? Non-flow work mo, again, 0. Okay? Constant volume, 0. Steady flow work mo, with this equation, integrate mo, you can arrive with this. B is equal to P1 minus P2. B quantity P1 minus P2. Or Q minus change in kinetic energy minus change in potential energy minus change in enthalpy. Change in internal energy mo, change M quantity U2 minus U1. Okay? Change specific internal energy minus 2 minus specific energy internal energy 1. Change in enthalpy mo, we have enthalpy 2 minus enthalpy 1 multiplied by your mass. Heat transfer mo is equal to change in internal energy, or Q is equal to M quantity U2 minus U1. Change in entropy mo is equal to mass times change in entropy. Isobaric process is a constant pressure process of pure substance. Again, we have PV and TS diagram. Ang PV diagram mo, pababa ulit yung pressure mo. Pero pataas ang volume mo. Dito naman, superheated, no? State 1 to state 2, superheated. Mixture to superheated. Okay? Non-flow work mo, from this equation again, your non-flow work is mass times your P pressure times the specific volume, change in specific volume, B2 minus B1. Steady flow work mo, from this equation again, negative, work mo 0. Since pressure mo constant. Okay? Ang change in internal energy mo, again, mass times the change in internal energy, specific internal energy. Change in enthalpy mo is mass times the change in enthalpy. Heat energy mo is Q. U2 minus U1 plus work. Non-flow work mo. Or H2 minus H1. Change in entropy mo again, mass times your change in entropy, S2 minus S1. Isothermal process. Isothermal process is an internal reversible constant temperature process of pure substance. Okay? Your PB and TS diagram from state 1 to state 2. Look at it. Superheated to vapor. Superheated to mixture. So, non-flow work mo, heat minus change in internal energy. Steady flow work mo is equal to heat minus kinetic energy minus potential energy minus your enthalpy. Change in enthalpy. Change in internal energy mo again, pareho pa rin dun sa mga nauna. Mass times your U2 minus U1 or internal energy. Change in enthalpy, pareho pa rin. Mass times your change in enthalpy. Heat transferred is equal to T temperature times change in entropy or is equal to T quantity S2 minus 1 minus S2. Change in entropy mo, mass times change in entropy. S2 minus S1. Specific yan. Isentropic or adiabatic process. Isentropic process is a constant entropy process of a pure substance. This is a process which no heat is transferred. So, 0 again ang heat mo naman dito. PV relation mo, look at it from state 1 to state 2. Rated. Okay. Non-flow work mo, Q minus change in U. Where Q is equal to 0 kasi it's adiabatic. So, non-flow work mo is change in internal energy. Steady flow work mo, since wala kang heat, so negative change in kinetic energy minus potential energy minus change in enthalpy. Since change in internal energy mo, again, the same. Mass times your change in specific internal energy. Change in enthalpy mo, again, mass times your specific enthalpy. Heat transfer mo, since this is adiabatic, change Q is equal to 0. Also, since it is isentropic or constant entropy process, so change in entropy mo, 0. Okay, isenthalpic or throttling process. Usually, nangyayari ito sa isang system is nandoon siya sa expansion valve, if you are familiar. Okay? Sa refrigeration cycle na meron kang condenser, then yung refrigerant mo, papasok siya sa, just imagine, meron kang condenser, then refrigerant mo, i-exit sa condenser, papasok siya sa expansion valve. Sa expansion valve, this is a device whereas usually the throttling process dito nangyayari or constant enthalpy or ang pressure mo nire-reduce dito. Okay? Nire-regulate ang iyong pressure dito. Expansion valve going to your evaporator, whereas the evaporator dito lumalamig yung refrigerant mo. That's why you can produce ice sa rep ninyo, refrigerator. Then going to compressor, then i-compress again the refrigerant, then babalik sa condenser, then magsa-cycle ulit. Okay? Matalastas lang yan. Isenthalpic process is a constant enthalpy process of a pure substance. It is a process in which no work is being done and is utilized in getting the quality of steam. Okay, PB and TS and HS diagram. Meron ka ng HS diagram or enthalpy-entropy diagram. Okay? And the mathematics involved, equation involved, we have H2 is equal to H1 since it is enthalpy constant or equal to HF1 plus X1 HFG. Okay, where can you find this? Again, thermodynamics table. H2 mo is equal to Hg plus Cp delta T approximately, where Cp for steam is 2 kilojoule per kilogram degree Kelvin, where change in T is equal to T2 minus your Tsat sa steam table ulit, thermodynamics table. So, learn it by heart. Okay? Next, we have steady flow, work sa enthalpy, 0. Change in internal energy, again, mass time the change in internal energy. Change in enthalpy, since it is constant enthalpy, 0. Heat transfer, 0. Change of entropy, mass times your change in entropy. Polytropic process. We have polytropic process is reversible process during which PB raised to N is equal to C or constant, where N is a constant. PB and TS diagram mo, okay, superheated lahat. Pababa nga lang. Non-flow work mo is equal to P2B2 minus P1B1 over 1 minus N. Steady flow work mo from this equation again, limit mo from 1 to 2, BDP naman, N is quantity, N quantity P2B2 minus P1B1 over 1 minus N. Whereas steady flow work mo is N times non-flow work mo. Or Q minus change in kinetic energy minus change in potential energy minus change in enthalpy with change in kinetic energy. Change in internal energy mo, again, mass times your change in specific internal energy. Change in enthalpy is kasi mass times your change in enthalpy. Heat transferred, Q is equal to change in internal energy plus your non-flow work. Then change in entropy, again, mass times change in entropy, S2 minus S1. Okay, again, we have here the highest efficiency cycle. We have Carnot cycle. Is the most efficient thermodynamic cycle. It consists of 2 isothermal and 2 isentropic process. Dalawang isothermal process or constant temperature at dalawang constant entropy process. Okay? Again, as you can see in here, you have heat added. Okay? Papasok, heat added. Okay? Papasok ng engine naman ulit, yung substance mo dyan. Work out. Palabas mo, heat sink or heat rejected. Papasok mo ulit sa pump, work input. Okay? Sa engine, work output. Okay, your P and B, PB diagram, as you can see, state 1 to state 2, ano nangyari? Bumaba ang pressure, pero tumaas ang volume. Okay? So, titingnan mo siya, i-compare mo sa TS diagram mo, temperature, entropy, ano nangyari sa 1 to 2? Constant temperature. Okay, constant temperature siya. Papunta ka ng 2 to 3, constant, constant entropy. 3 to 4, constant temperature. Again, pabalik sa 1, constant temperature. So, that is your process. Process 1 to 2 is entropic. 2 to 3 is thermal. Process 3 to 4 is entropy compression. Process 4 to 1 isothermal expansion. Okay? So, analysis of the Carnot cycle, heat added mo, or QA, is equal to T1 quantity, entropy mo, S1 minus S4. Okay, S4 ka. Bakit? Dito ka, work input. Punta doon. Ang heat rejected mo, dito naman, dito sa heat sink, QR is equal to T2 S2 minus S3 or QR T2 S1 minus S4. Net work or work done mo is your heat added minus heat rejected. Ang work net mo is T1 minus T2 quantity times quantity S1 minus S4. Cycle efficiency mo, work net over Q heat added or is equal to 1 minus Q rejected over heat added. Or you can use this normally. You can also use dimensional, you can also derive some formulas here to get your T1 or T2, ganyan. Efficiency is equal to T1 minus T2 over T1 or 1 minus T2 over T1. Heat temperature relation mo, QR over QA is equal to T2 over T1. Note that take note, Carnot cycle efficiency can be increased by increasing T1 and lowering T2. So, probably that will be all. Thank you so much.